Okay, 1.5 talks about equations. Equations, the property of equations is that given two values that are equal, I'm allowed to add the same quantity to both sides, that is, adding a zero. Equivalently, if I have a equal b, I could add and subtract c to the right side or to the left side. That's allowed, that's not changing anything. And the second case, if a equal b, if I have two quantities that are equal, I'm allowed to multiply both sides by the same number as long as that number is not zero. And keep in mind, if I divide by c, I'm really multiplying by 1. So you're allowed in math to add a 0 and multiply by 1, and that's about it. To solve any equation in mathematics, you isolate the name on one side of the equation and proceed. I'll elaborate on that as we do problems. Linear equations. A linear equation in one variable can be written in the form of ax plus b, where a and b are real numbers and x is the variable. So linear means the power in the variables equal 1. We're going to start with linear equations first. Solve the following linear equations. Well, to solve linear equations, we get the variables on one side, subtract 2x from both sides, and reverse order operations. Once you get a variable on one side, add 7 to both sides, divide by 3 both sides. And there it is. If I see a set of parentheses, I clear the parentheses, get rid of those parentheses, simplify each side first, and get the variables on one side, and reverse order operations, divide by 13, 0 over any number other than 0 is 0. A lot of times you're going to see fractions and decimals. LCD with equations will be really what you want to go after. It's a 6. If all the terms, if it's an equation and all the terms have the same denominator, then you really don't need it. What's the 2 missing to have the whole LCD? A 3. The 3 missing a 2. Now that the fact that all of those are over 6 and it's an equation, you just read the top. 6 times 3, that becomes 18, minus 3 times x equals 1 times 2 plus x. And that's how you get around all fractions. And when I get the decimals, I'll show you the same thing. So we're going to move the variable to one side. Again, it's a good habit to move the smaller to the larger. You don't have to, but that's a good habit to start with. That negative 3x, when moved to the right, becomes positive 3x plus x, that's 4x. Subtract 2 from both sides, and divide by 4. 16 divided by 4 is a 4. Instead of numbers, we're going to be dealing with variables. Solve the following for the indicated variables. Well, alright. I'm glancing, I want a y. I notice a y, there's only one of those. I reverse order operations, that is, get rid of things that are added or subtracted. And since I want a y, since the b is being multiplied by y, I divide. So you could either divide the whole side or you could divide the pieces. It really doesn't matter. Those are the same thing. You could say c over b minus ax over b. Again, it makes no difference which of those two you write. Those two are saying the same thing. If we're talking about equations of lines, then not probably, this is the way to go. But those are equivalent. Here, I want to solve this for R2. I see a fraction. The first thing that should come to my mind, what's the LCD? R, R1, R2. So what is this missing to have the whole LCD? R1, R2. Whatever you multiply the bottom with, you multiply the top with. This is missing an R, R2. and this is missing an R1. Since this is an equation again, you ignore the denominators, you read just the top, that reads R1 R2 equals R2 plus R1. Since you want R1 by itself, move all the R sub 1's to one side. And if you want to solve for R sub 2, you reverse the distributive property where you factor R1 out. You'll be left with R2 minus R. And of course, R1 equal R2. You would divide both sides by that parentheses. And there it is. And that's what R sub 1 will equal. And if I look at part C, that's the surface area of a rectangular prism. Not that it matters. We want to solve for H. You isolate the H on one side, everything else on the other side. That's 2LH. 21, it makes no difference really, it's the same process. We notice that H appears in both of those. We factor that out. And if you want to find H, you divide by that parentheses both sides, and that does the trick. If I want to solve this equation for x, again, a couple of ways you could do this really. I know you're tempted to distribute, you can if you want, but it'll be easier for you to move everything with an x to one side. And since it is the x that you want, factor an x out of both of those. That would leave me with a c minus 1 minus a squared. And if you want x by itself, divide both sides by that parentheses. No matter how you solve this problem, you get the same answer. If you distribute first and proceed, you get the same thing. And if I see a fraction, and that's going to happen a lot for us, we clear the fractions first. What's the LCD? That's A, B, C. The first fraction is missing a BC. The second fraction is missing an AC. And the last is missing AB. Now that this is an equation, they all have the same denominator. Well, that's going to be BC times x plus 1 plus AC times x minus 1 equals ABX. Get rid of the parentheses. BCX plus BC plus ACX minus AC equal ABX. So get all the x's on one side, all the non-x's on the other side. So BCX plus ACX. When I move this to the left, it becomes a minus ABX. The right side, I'm going to have a positive AC and a negative BC. Since it's x that I'm after, factor an x out of all of those. You would be left with BC plus AC minus AB equaling AC minus BC. And if you want x, divide both sides by that parentheses. I'll be left with AC minus BC all over BC plus AC minus AB. And there it is. So linear equations mainly work that way. Quadratics are a bit different. A quadratic equation in one variable is of the form ax squared plus bx plus c equals 0, in which a cannot equal 0, otherwise that's linear, and b and c could be any numbers. And why do we factor? Because if you take addition and subtraction equaling 0 and change it to multiplication equals 0, the only way I could multiply two quantities and get a 0 if one of them is a 0. So we're trying to solve quadratic equations. We try to factor first. Well, does this factor? Well, yeah, it does. 1 and 1. Closest factors of 18 are, let me see, 6 and 3 don't work. 9 and 2. Subtract to get me 7. 2 minus 9 is 7, so I want a negative. The 9 should be negative and the 2 should be positive. So that's x minus 9 and an x plus 2. Now, if two factors equal 0, that means either the first equals 0 or the second equals 0. So, solve this linear equation. X would be a 9 or a negative 2. Those would be the two values that satisfy this equation, which indicates that these are solutions. Next problem, I'm trying to figure out where does these two equal a 5. That's a bit tougher than it looks. So what we do, we write it as a standard quadratic equation and see if we could factor it. Factors of 6 are 2 and 3. 5, again, since that's not 1 and 1, you're going to write it both ways. You want to subtract to get you 13. 2 minus 15 is 13. That works. Perfect. So I have a 15 and a 2. To get a positive 13, 15 should be positive, 2 should be negative. Carry over. So that's 2x plus 5 and a 3x minus 1. Again, I would take this. So, okay, well, that means 2x plus 5 must be 0, or 3x minus 1 must be 0. Subtract 5 from both sides and divide by 2. X would be either a negative 5 halves or x would be a 1/3. And of course you could write it like this if you wish, that's the same thing. And if I get to the next problem, same deal, I'll try to get everything on one side if I can and factor. So factors of 2 are 2 and 1, factors of 25 are 5 and 5. I need to subtract to get me a 10. 10 minus 5 is 5, that works. I want a positive 5, so the 10 should be positive and the 5 should be negative. So 2x minus 5 and an x plus 5. So that means 2x minus 5 will equal a 0, or x plus 5 will equal a 0. So x is either 5 halves or a negative 5. So quadratic equations work this way. First you try to factor, and if it doesn't factor, then you would either complete the square or use the quadratic formula, and here we are. Square root property says if x squared equal a and a is bigger than 0, then x equal plus or minus radical a. Well, first problem is right there. If I get everything on one side 0 on the other side, I'll notice I can't factor. This is prime because that's not a perfect square. Instead, if I was to square root both sides, I will get x to be a plus or minus radical 5. So the square root property allows me to solve perfect square problems. If I'm looking at this problem, I try to factor, but there are no two factors of 4 that subtract to get me an 8. That's not possible. So what I do, I'll complete the square. I'll take x squared plus 8x, leave some space, and what I'll do, I'll add a number to both sides of the equation. And if you remember, that number is half of that number. Half of 8 squared. Half of 8 is 4, and you square it, you get a 16. That makes this a perfect squared, and that becomes x with that sign, the number before we squared it. 4 plus 16 is a 20. Now that I have a perfect square equal a, I square root both sides. And move that 4 over. And we know that 20 is 4 times 5. That clears the radical as a 2. And there's my answer. So, if it doesn't factor, you have two options. Either you complete the square or use a quadratic formula. And we want to do both. And if I look at the next problem, the same deal, that doesn't factor. But to complete the square, the leading coefficient must be a 1. So if it's not a 1, I force it to be a 1. I get x squared plus 4x, and I'm going to number to both sides of the equation. Take half of the middle number. Half of 4 is 2, and square that, we get a 4. That guarantees that this side becomes a perfect square. X with that sign, the number before I squared it. The right side, if I get a common denominator, that's 12 plus 1, 13 over 3. So if I square root both sides, I'll get x plus 2 to equal plus or minus radical 13 over radical 3. Move the 2 over. And if I rationalize this, I'll get the square root of 39 divided by 3. And that would be my final answer. Okay. One more. Same deal, this doesn't factor. To complete the square, I need the leading coefficient to be a 1. It is a 1. I'm going to change this problem just to make it more fun. I'm going to make that a 3. So how does it work? You take half of the middle number. Half of 3 is 3 halves, and if you square 3 halves, you get 9/4. This becomes a perfect square. X, always with that sign, the number before you square it. And if I get a common denominator, that's over 1. 16 plus 9 is 25. So that would indicate, oh, the reason I didn't have a 3 before, because now it factors. But that's okay. X minus 3 halves equals plus or minus, and if I square it both sides, the square root of 25 over 2 is 5 halves. Move the 3 halves over. So if I take this, 3 plus 5 is 8 over 2 is 4. 3 minus 5 is negative 2, divided by 2 is negative 1. Okay, we're going to stop this video here, and I'll continue it on the next.